Good afternoon, everybody, and welcome to the homework helper of 1.7. We're going to go through today's homework, give it a last little look over. This is the last homework of the week, and so tomorrow, you may have noticed that there's no 1.8. We're going to be doing something slightly different, but it's going to be very much based on understanding what's going on in these activities we've done in class and in the homework. So we're going to start with this very first section, this ready section. And what I want you to begin to see is that it wants you to distinguish between the arithmetic and geometric sequences. So what you're going to have to be able to do is identify whether it has a common difference or a common ratio, because at the heart of everything, that's going to be the major difference between our arithmetic and geometric. So let me break that down real fast on a sticky note. So arithmetic versus geometric. And so the arithmetic, we already know we add or subtract each term, and for geometric, we are multiplying or dividing. But for the arithmetic, that also means that we have something we call the common difference, but in geometric, it's known as the common ratio. We know that the base form of recursive is f of x equals f of x. F of x minus 1 plus our common difference. Whereas for geometrics, let me make a little line here so we don't get too confused. We have f of x equals f of x minus 1 times our common ratio. And we know that our explicit form, it's going to be f of x equals my common difference times x plus my n sub 0. While for geometric, it's going to be f of x equals my first term times my common ratio to the x minus 1 power, or, and I'm not sure if this came up in class or not, f of x equals our 0th term times our common ratio to the x power. Whichever one is easier for us to figure out. So this note card right here has a lot of really important information on it. Let's go ahead and just do a little zoom in. Let's do a little zoom in on that. Let's do a little zoom out. It's a little too close. So, screenshot this, copy this down, pause the video so that you can make sure you get these differences, because these differences are really going to be key when we look at the differences between these. So let's go ahead and zoom out again so that we can actually see the problem that we're working on. So when we're looking at this sequence, 5, 10, 15, we have to figure out whether or not it's a common difference or a common ratio. So you have to be able to discern whether we're adding a number at each step or if we're multiplying by a number each step. So for this, I could see this as either plus 5 or I could see it as times 2. Now when I go from 10 to 15, did I add 5? Or did I times 2? And I can see that I added 5. So I know that it's going to be a difference because I'm adding the same number. And so that's going to tell me that the common difference is 5, meaning that this is 20 and 35. And of course, that means it's arithmetic. Easy enough? And so we can do the same thing here, except this time we're missing a step, right? So I'm either subtracting 10 or I'm multiplying, or I should say I'm dividing by 2. Now I'm missing a step, so either I'm subtracting 10 and subtracting 10, or I'm dividing by 2, dividing by 2. And well, if I subtracted 10, I'd have 0. If I subtracted 10, I'd have negative 10, which isn't what's going on. But if I divided by 2, I'd have 5, and then if I divided by 2, I'd have 2.5. So I can see that this is a ratio of dividing by 2 or multiplying by a half. Those are the same thing. And then this would be 1.25, and I can tell it's a geometric relationship. And so that's what it's asking me to do for these ones. Now again, what we're going to be doing for the set section is, again, we're trying to determine if it's arithmetic or geometric. So we're going to use the same skills we used in that first section to figure that out. Then it wants us to write recursive and explicit. So we look at this again, and I see this is either plus 2, or times 2, but that's not times 2, so I can tell that it's arithmetic, and my common difference is 2. I'm adding 2 at each step. So my recursive, all I have to do is refer back to this. I see that f of x is f of x minus 1 plus 2, because all I did was put in 2 for my common difference. And my explicit form would be f of x equals 2x. And then what's my 0th term? Well, my first term was 2, and I add 2, so it would be 0, so I'm just done. That's all I have to do. And then likewise for this one, this is either plus 2, but is that plus 2? No, that's plus 4. But this is times 2, times 2. I can see that it's geometric with a common ratio of times 2. So I know that my recursive equation is f of x equals f of x minus 1 times 2, because that's my common ratio. And I know that my explicit form is going to be f of x equals my first term, which is 2, times my common ratio, which is 2, to the x minus 1 power. And one of the cool things you can see here is that these are both 2, right? These are both 2. This is kind of like an extended. This is like an extension. So don't worry too much about this, but this is an extended lesson. And so I kind of want to just talk about this because it's kind of a cool thing that happens for some of these geometric explicits. You'll see that we have f of x equals 2 times 2 to the x minus 1. And so what I want us to see is that really there's a little 1 right here. We're always raising anything to the first power. We just don't bother writing that for everything because it would take forever if we wrote little 1s everywhere. It's like how we're always adding 0. If I wrote plus 0 on everything, I'd be writing plus 0 forever. So we just assume that it's there, we don't write it. But it is there. There's this little 1. And so when I think about 2 times 2, what I end up doing is I end up adding their powers. So this, let me get a different color here. So this is actually being added to that. So what I really have is 2 to the 1 plus the x minus 1 power. And so these parentheses, since this is just plus here, aren't doing anything. So really that's 2 to the 1 plus x minus 1 power. And 1 minus 1 is 0. So this really is just 2 to the x. So I could even simplify this further as just saying 2 to the x power. Now, I'm not expecting you to be able to see this all the time, but I do want you to be mindful of it as we move forward, because eventually I want you to be able to see this. But right now, if you were to give me this answer right here, I would be incredibly happy because you're making the connection of the explicit terms here. Alrighty, let's go ahead and turn the page. This is more of the same, except this time it's giving it to us in a table. So again, these are our term numbers, and so you just need to see what the pattern is here to see if it's being multiplied or added to determine whether it's arithmetic or geometric. And then I've heard a couple people having problems with the word problems. I really strongly recommend that you look at these word problems and try to build a chart like these. That's my initial response to everything. Like, Michelle likes chocolate, but it causes acne. Well, ain't that the truth? She chooses to limit herself to 3 chocolate bars every 5 days. So she eats part of a bar every day. So if you're doing 3 chocolate bars for every 5 days, you're doing 3/5 of a chocolate bar. So on day 0, she had 0. On day 1, she had 3/5. On day 2, she had 6/5. On day 3, she had 9/5. Etc., etc. And so we keep adding it up. And so then we can kind of better, easier see that, yeah, this is arithmetic. I'm adding 3/5 each time. So I have f of x equals f of x minus 1 plus 3/5. And so the explicit form is f of x equals my common difference, 3/5 x, plus my n sub 0, which is 0. So I just leave it, and I'm done. But really build these charts when you see what's going on, because that'll help you make sense of whether it's going to be arithmetic or geometric, because you can see the pattern. Now, sometimes you can pick up words from the story context to see which one it is. 3 every day, so she's eating 3 every day, kind of sounds like she's adding it every 5 days. You can kind of figure it out. Each ride is telling us that it's 1. Double means multiplication, okay? And then this is like telling us percent interest, so that's going to be multiplication as well. So we can kind of tell from some of these clues what exactly we're going to be doing. Okay, finally. We're going to be doing graphing and counting the slope between 2 points. So what this is going to be doing is it's going to give us 2 points, A and B. So in this case, A is 2, negative 1. And remember, it always goes X, comma, Y. And this is our X, and this is our Y. So Y goes up and down, X goes over and over. So X is at 2, so I go over 1, 2. So I know my X is going to be somewhere on this line. My dot, my point is somewhere on the X equals 2 line. Y is negative 1, so this is 0, so I go down to negative 1. So I know my Y is going to be on this line, and there's only one place where it happens at the same time, and it's right there. Here is A. And then for B, it's 4, 2, so I go over 1, 2, 3, 4 on my X, and up 1, 2 on my Y, and here is B. And so now I need to show where the slope is. So the slope means that any 2 points make a line. So I'm going to be I'm not going to use a ruler because I don't have one right in front of me, but I'll use this. So what I've done is I created a straight line here, and we might want to know what the slope of this is, and how we calculate it is we see how it travels. It goes up 3 and over 2, 3, 2. And so when we care about slope is, we might say rise over run. And by rise, we mean our up and down motion, and by run, we mean our left and right motion. Now, up and down is y, so another way I like to say this is our change in y over our change in x. Okay? So to do this, I see that A to B, I have to go up 3. So my rise, my upward motion, my change in y is 3. And I see to go from A to B, I have to go over 2. 2 is my run. 2 is my left and right motion. 2 is my change in x. 2. So we would say that the slope of this is 3/2, which it tells us. But what I want to see from you on these is that you're making the visual connection that 3, 2 is how we get that 3/2. All right? And so there's just a few more problems like that. These ones at the bottom ask you to write down the slope. It doesn't give you that safety net of telling you what the slope is. So be mindful of that. And that, as they say, is that. That's going to be the end of this packet. Come tomorrow with this completely done. We're not going to be spending it working on this. We're going to be working on something else to try to solidify our understanding of recursion, explicit, arithmetic, and geometric. So thank you very much and have a lovely day. See you tomorrow.